Hey everybody, Mr. B back to talk to you today about genetic disorders. For those of you that haven't read in your book yet, these disorders are diseases that are generally caused by an abnormality in an individual's DNA. Now, those abnormalities can occur in several different ways. First of all, you could have a recessive condition or a dominant condition that exists in any one of your chromosomes that is not the sex chromosome. Those would be your autosomal, or your autosomes, as they're scientifically referred to as. Or you could have one that's X-linked. That being, an example of that would be colorblindness, which we talked about in the X-linked trait video. You could also have a chromosome disorder, where either you don't have enough chromosomes or you have extra chromosomes. Those abnormalities also kind of range into the multifactorial zone, where there's multiple factors in play with respect to certain diseases. For example, obesity, heart disease. Not only do people have a genetic predisposition to these specific disorders, but there could also be some lifestyle or external factors that may push certain groups of people into those particular categories. So let's explore some of these specific disorders that are listed as examples. For instance, cystic fibrosis. Here we have one of those autosomal recessive disorders, and I really, really like this diagram because it gives us a nice, clear picture of how a person's offspring could end up getting this particular type of disorder. So with an autosomal recessive, basically what we have happening here in the diagram is you've got a mom that's a carrier, which would mean that they have not only the recessive allele, but also the dominant allele for cystic fibrosis. And your father is set up with the same genotype, dominant and recessive alleles for the cystic fibrosis gene. Combinations, if you take a look, 1 in 4 of those kids has the possibility of being affected, which is, if you're talking probability, about a 25% chance. Now, the only way for a person to be affected by cystic fibrosis here in this case would be obviously for mom and dad to both donate or give that recessive allele to their child. If they get both recessive alleles, there isn't an opportunity for a dominant allele to mask it, which would be the case with a carrier for this autosomal condition. So this is one mutation in a single gene that is linked to that recessive and how you pass it on, I should say. So moving on, another single gene mutation which is dominant. All right, so there's no way of masking this particular gene, or this particular allele would be here with Huntington's disease. With the case of Huntington's, you have a father here that's affected. Whether they're going to be a dominant allele situation or a dominant recessive allele situation is kind of vital here. I want you to stop and think here with the possible combinations. What do you think the dad's genotype is for this? Do you think it's a dominant, or do you think it's a dominant recessive genotype? Go ahead, pause and think about this for a sec. All right, hopefully you said that the dad in this case is going to be heterozygous for Huntington's disease, or have the dominant and recessive allele. Because if you take a look at the possibilities here, or the possible combinations for these two set of parents, you have the ability for a child to come out with not having Huntington's, which is obviously the best route. So that is your dominant allele situation. As far as the sex-linked variety, there are a couple different scenarios that you can kind of work your way through. One with mom being a carrier and dad being normal, and one with mom being a carrier and dad being affected. Now, if you take a look at scenario 2, the only way for you to get a female to be affected by an X-linked trait would be to have the dad automatically be affected by it, because that father with its daughter will donate his X chromosome to her, and if there is any issue with it, any mutation, that child will be given it as well. So we talked more about the sex-linked traits back in that sex-linked video. So if you have any questions with that, obviously either refer back to that video, or the best solution would be to come see me for an answer. Some chromosome disorders. Again, I mentioned earlier on that either you can have too many or too few of these. Here's trisomy 21, or Down syndrome, with the resulting trisomy at the 21st chromosome pair. We have another case here with Turner syndrome. This one is different. It's not as well known as Down syndrome. If you take a look at the sex chromosomes, you'll see that this individual is missing the Y chromosome and a second X chromosome. So either way, there's only one sex chromosome in this person's set of chromosomes, which here would imply an abnormality, which is a subtraction of a chromosome. If you're interested in learning more about Turner syndrome, which does display some developmental issues, please let me know, and we'll possibly make that one of the brochures that you go ahead and study a little bit later on in this unit. Lastly, the multifactorial inheritance disorder. This is again caused by a combination of small inherited variations in genes that kind of often acting together with environmental factors can lead to some issues. Your examples of diabetes, most types of cancer, such as usually lung cancer, breast cancer, and even heart disease are multifactorial inheritance situations. Again, if you're interested or have any questions in or with the multifactorial inheritance disorders, please feel free to let me know. We'll be exploring these more, or give you the opportunity to explore them more in our extension menu. However, for the most part, our genetics unit, as far as the disorder realm, will kind of exist mainly in those autosomal disorders with the single gene mutations, as well as the chromosomal abnormalities. So again, if anything comes up for you in the videos here with respect to not only the disorder aspects, but also anything regarding Punnett squares, sex-linked traits, the different types of dominance, how chromosomes are, what chromosomes are composed of, please let me know, and we'll definitely address those issues as they come up. So again, this is Mr. B signing off. If you got any questions, come see me.